Okay, let's talk about percent increases. In the last video, we talked about percent decreases. So with a percent increase, we're still going to do the same method. We're going to find that percent of change of the original amount. But in this instance, we're going to add it. Okay, now percent increases can fall under three categories. Obviously more than three, but the three we'll look at the most is sales tax, everyone's favorite percent increase, markups. Okay, so if you're buying things, you can't sell it for what you paid for it, you won't make any money, and just straight up percent increases. Okay, so we'll look at some examples here. We're going to look at the sales tax one, but again, kind of like the discounts or percent decrease, however you write it, they're all solved the same way. Okay, so and remember, with any kind of percent change, that change is based off the original amount, where it started. Whether the number went up or down, wherever it started, that's what goes across from the 100% in your proportion. Okay, so we look at this one. They said if an item costs $13.50 and the sales tax is 7.5%, what is the price with the tax included? Okay, so let's set this one up as a proportion. So you get 100%. So the 7.5, we should know where that goes automatically. It's a percentage. So it goes over 100. And the 13.50 will go down here. X on top. So we do X times 100. That gives me 100X. 7.5 times 13.50. Let's see, let's pull that up. I think I had that preloaded on my calculator. Yep, I did. Thinking ahead. Let's see, so that gives me 101.25. Okay, then we divide by 100. Divide this by 100. So those cancel out. I'm left with X. So that'll give me, move that over twice, gives me 1.0125. Now we're talking about money here, okay? I've talked to a bunch of different business professors, and it's kind of depends who you talk to, the answer you get on this one. So I know with this one, the lowest denomination we have for money is the penny. So some people say round it off right now. Some people say use this number to the full end. When I look at this one, I'm just going to round it off, okay? And again, like, if you ever take business classes, just listen to their opinion. But, for this class, we're just going to round it off to the nearest penny. If for whatever reason you don't, just make sure your final answer is rounded off to the nearest penny. And obviously show it in your work so I can backtrack and see what you're doing. Let's see. So now we found the 101. So this is an increase. So now I take the 13.50. You still got to pay what the item costs, plus the 1.01. So I'm going to pay $14.51 for that item. Okay, so again, just kind of like the discounts, there's another way you can do this without having to figure in for this adding part, okay, with the percent increase side of the spectrum. And it's a little bit easier. Because again, it's like if you're just trying to get to the new amount, this way will serve you better. So we think about this. 100% right here. The 13.50 is the original price, so that automatically goes across from 100. Always. The original price always goes across from 100. I know I'm being kind of redundant with that one, but it's just so you can get that in your mind. So we look at this one. We think about this practically with the decrease or the discount we talked about in the last video. We took the percent of change, which in this case is 7.5%, and we subtracted it. But we know tax is an increase, so we should probably add this, because if you think about this, 13.50 represents 100%, 101 represents 7.5%. So if I add those two together, the new price is actually 107.5%. So if I put 107.5 up here instead of 7.5, that'll take me straight to my answer, or the answer with the tax included. So we do 100 times x, that gives me 100x. 107.5 times 13.50. Let's see, let me pull my calculator up here. 107.5 times 13.50. So that gives me 1451.25. Let's write that in here. 1451.25. So now we divide both sides by 100. These cancel out. I'm left with x. So that gives me 1451.25. And again, we're talking about nearest penny here, so we can just round that down to, again, anytime you see the wavy equal sign, that just means the number's rounded. So that'll give me $14.51. Same answer both times. Okay, so it's kind of up to you which way you want to figure this. But again, all percent increases can be figured the same way. You know, I mean, even if they said this wasn't 1350, you know, it's like you just have the number 13.5 and you increase it by 7.5%. This is the method you use. Okay, you know, it doesn't matter what the story problem is. It's a percent increase. So you can either find the percent of change and add it on, or you can find the percent added on to 100, and that'll get you to your new amount. Now again, kind of like the discount ones, there are ways they can kind of trick you with this, or you know, do things that make your mind, or play tricks with your mind. Let's see, let's go right here. And again, with this one, you might see a question oddly similar to this one on the test for this module. Hint, hint, hint. They say if an item costs $36.50 and you paid $37.99, what was the sales tax percentage? So we look at this one, where a lot of people screw up with this one is they forget the original amount goes across from 100. So we got 100 right here. We're looking for a percent, so we automatically know the X is on top. Now we look at this one, where did it start? It started at $36.50 and it ended up at $37.99. I actually had a student say this in class the other day, that what the amount you actually paid always goes on top. And that's a good way to think about it too. So, you know, we actually paid $37.99, but it cost $36.50. So $36.50 goes across my 100. And a lot of people want to put the small number over the big number, but remember, it's where it started, not where it ended up. So we put $37.99 on top, and we cross multiply. Let's see, so that gives me 3,799. We do X times that, that's 3650X, and divide both sides by 3650. Divide this by 3650. Okay, and again, there's different ways you can do this. Everyone kind of interprets things differently. I'm just trying to show you the way most people set it up. Okay, let's see. So let's do the division there. So 37.99 divided by 36.50. So we get 104. I get a really big number there. You know, that's generally what you'll find when you get into, like, I always say, real life numbers, not just math book numbers. You get really crappy numbers like this. So let's just round it off to the nearest hundredth. So we get 104 point, I forgot what the number was, 0.08. That's what I thought. Let's see. 0.08. So we look at this, you think about this, a lot of people just leave the answer like this, but we think about it, okay, this number we put up here over the original, this has the original amount and the increase included in it. That's why we're getting the 100%. So the actual increase is only 4.08%. Okay, because the 100 is in there because we got full price in there. So when you think about this, when you find these numbers, again, you know, kind of ask yourself, you know, does it make sense? Does it fit the context of the problem? And in this case, a 4% increase from 36.50 to 37.99, that makes more sense than a 104% increase. That'd be way too small a number for that kind of increase. Okay, so when you look at these things, you know, percent increase or whether it's percent decrease, they're all kind of solved the same way. You know, there's two different ways you can interpret it. You can either find the percent of change and add or subtract that number you get after that, or you can kind of cut to the chase like we did in the example up here, where it's like I can just go, okay, I have a 7.5% increase, so if I just add that on to 100, that'll take me straight to my answer. Okay, so it just kind of depends what you're looking for, but ultimately, you know, they can be quick one-step problems.